ready to the countdown.
Congratulations! This live broadcast is specially brought to you by Academy YouTuber Malaysia, an initiative by Didik Malaysia and Kelab Guru Malaysia. Please pay attention. The live broadcast will begin shortly. The link to the certificate of attendance will be provided at the end of the session. Please make sure it is filled within the stipulated time. Thank you.
Okay, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. Good evening and hi teachers, parents and all wonderful students. Welcome to Pusat Tuisyen Academy YouTuber, a joint venture with Didik Malaysia and Kelab Guru Malaysia with the hashtag bermula percuma, selamanya percuma. So before we proceed, let's begin our session with the recitation of the Kitab for the Muslim and a moment of silence for the non-Muslim. Al-Fatiha. So how's everyone today? My prayer that everyone is in the best of health and ready to proceed with today's class. Before we start, let me introduce myself as usual. My name is Nun binti Muhammad Noh. You can call me Madam Nun. I am lecturer from College Matrikulasi Negeri Sembilan. I am your moderator for today's class. So the most important person today is our passionate and fantastic presenter, Madam Rosmaya. She is a very experienced teacher from SMJK Yuhua Kajang Selangor. So let us give a warm welcome to our speaker or presenter. Okay, for the record, we are now live on Madam Rosmaya channel. So as a sign of support to Madam Rosmaya for the hard work in preparing today's lesson, please subscribe her channel. And as usual, the lesson will last approximately 1 hour. So the certificate link and the credit claim link will be given at the end of this session. Remember that you can only use e-didik email to claim the certificate. For credit claim, you need to collect the 1 letter and 4-digit code which will be announced separately during our class today. So be sure to follow the class up until the end to get the complete code for the credit claim. I would also like to remind students, if you wish to post comment in the chat box, please use appropriate language and use appropriate profile picture. I am pretty sure all students here are excellent students who will uphold a positive classroom environment. Please give your full cooperation in making this class a lively one. Stay focused, and if you have any question, please write on the chat box and we will try to provide you with the answers. Before I give to Madam Rosmaya to present, I will announce the first digit code for credit claim. So make sure that you write down somewhere, yeah? So the digit is A16. A16. Okay? So without further ado, please welcome Madam Rosmaya to start her presentation. Okay, Madam Rosmaya, you can start. Thank you.
Okay, hi everyone. Thank you to our moderator, for today, Cikgu Nun. Okay, so now I'm going to open my slide. Okay, that's my slide open already. Let me introduce the pre-U teams that we have in Academy YouTuber first. Okay, so this is a physics team, okay, lead by me, okay, Madam Rosmaya. So Cikgu Nun is one of the member in the physics pre-U team. Okay, next we have maths team, okay, lead by teacher Im. Okay. Okay, next we have biology team lead by Cikgu Faiza. Okay, next we have chemistry team lead by Cikgu Shahnon. And Madam Fizi lead perakaunan and ekonomi pre-U. Okay, besides that, other subject like STPM subject, pengajian MURID, pengajian perniagaan perakaunan from STPM, also in the academy YouTuber, in the category of pre-U, pre-U subject. Okay, so Academy YouTuber also has apps, okay, where you can download it from Google Store, and there are a lot of videos there, including the physics videos. Okay, so now we have come to our main objective for today, okay, live tuition class. So what is our learning objective for today? So our objective is to solve problems on thermodynamic of gases. Okay, now we go straight to the first question. Okay, I posted already the question PDF in the description below this video. In the chat box here also got in the earlier in the chat box you can see there's a link question PDF you can download from there. Okay, so let's look at this first question. We read the question first. Okay, using the first law of thermodynamics and the ideal gas law, show that CPM equals to CVM plus R. So CPM is the molar heat capacity at constant pressure, and CVM is the molar heat capacity at constant volume. Okay, and R is the gas constant. Okay, so how to prove this equation? Actually, this question is a past year question. So this is the derivation question. Okay, so the solution. Okay, the question asks to use first law of thermodynamics. So you better state down the first law of thermodynamics. Okay, this one got marks. Okay, so by the first law of thermodynamics, okay, Q equals to delta U plus W. Okay, so Q is the heat supplied or heat loss, and delta U is the change in internal energy, and W is the work done. Okay, so we divide into two. Okay, Okay, the first one for the case where for n moles of gas that are heated at constant volume. So we are going to substitute this Q equals to NCV delta T. Okay, so we substitute Q here. And then because of constant volume, so from the work equals to pressure times change in volume. So the volume is zero. Change in volume is zero. So therefore, the work done is zero. Okay, no changes in volume. So the work done is zero. So you can get change in internal energy here as N CVM delta T. So the T is the temperature, change in temperature. Okay, so you must memorize this equation too, not given in the exam. So delta U equals to NCVM delta T. Okay, next we go to the case where for the n moles of gas that are heated at constant pressure. Okay, so using the Q equals to NCPM delta T. Okay, this is the heat formula. Q equals to NCPM delta T. So for constant pressure, we use this here straight away, and then equals to delta U plus work done. So the work done, because it has volume changes, so therefore we can use this PV equals to nRT, delta T. So nR delta T, we substitute into the first law of thermodynamics. So now we can cancel out all the n here. Okay, then we can also cancel out the change in temperature. Okay, so there's a typing error here. This T supposed to be capital letter T. Okay, so cancel out the change in temperature. So we get CPM equals to CVM plus R. Okay, so this means that we have proof. The formula is proven. Okay, so done for this question. Okay, next we go to the next question. So if you done this question already and you got proven, okay, you can write there in the chat box so that we all our teachers here can see, can give you a clap. You've done this question and you are success in writing this, solving this question. Okay, so next we go to question 2. Okay, actually this question is the continuation from the first question. If you refer to the past year question, so question 1 and question 2 is in one set, one set question, essay question. But I separate them. Okay, so let's solve this question. So we read the question first. A gas with gamma, okay, this gamma is the ratio of CPM to CVM. Okay, so gamma equals to 1.40 initially at temperature 30.0 degrees Celsius, and volume is 3.50 times 10 to the power of negative 3 meter cube, and pressure is 1.013 times 10 to the power of 5 Pascal. So undergoes an adiabatic compression to 1/3 of its original volume. So assuming the gas behaves as an ideal gas, okay, state the type of gas molecules used, and then calculate the final pressure of the gas. And question C, determine the amount of work done on the gas. Okay, so the solution. Okay, state the type of gas molecules used. Okay, it's a diatomic because you know it from the gamma given here. Okay, so gamma 1.40 means that the gas is the diatomic gas. Okay, so how we know that the gas is diatomic from the gamma value 1.40? So we do revision in here. Actually, the question just asked it, diatomic, but it's okay. We who knows, in the they might change the question to for derivation question, right? So let's discuss this in detail. So how we got this? 1.40 is a diatomic. So we know that gamma is ratio of principal molar heat capacities. Okay, so the formula is gamma equals to CPM per CVM. Okay, so let's say we take 1 mole of ideal gas has internal energy U equals to half NFRT. So we are going to relate the internal energy with the degree of freedom. So this is the relationship between internal energy and degree of freedom, F. So for 1 mole, we take N as 1 here, substitute into here, so we get half FRT. Okay, so now from the formula that we derived in question 1 previous, as been in the previous slide, so we get change in internal energy equals to NVM delta T. Okay, so we rearrange this equation. So for we use derivation rules for approximation, we get CVM equals to du by dt. Okay, so N is 1, right, for 1 mole. So you can substitute U here and use differentiation rule for half FRT. Okay, d half FRT by dt. So when we differentiate this, we get half FR. Okay, half FR. So the T here actually the what you call this temperature, so supposed to use a capital letter, but it's okay. This typing error here. So that means CVM equals to half FR. Okay, so you can see the relationship between CVM and degree of freedom. Okay, next we are going to use the equation in question 1. Then you substitute into here, we can get CPM equals to half FR plus R. Okay, factor out R here, so we can get half bracket F plus 2 times R. Okay. Okay, so now these two equation we can substitute into the gamma here, So these two, CVM equals to half FR and CPM, molar heat capacity at constant pressure, half bracket F plus 2 times R. So now you substitute into here. Okay, so what you get? For F equals to 3, okay, so the substitute 3 into here, so half 3 plus 2, and then divided by half FR, right? CVM is half FR, so half times 3R. So you get 1.67, 1.67. So we do the same for diatomic. We know that the degree of freedom is 5, okay, the number of degree of freedom is 5. So we substitute into the equation here, CPM and CVM into here. So F is 5, so you get 1.4. there is where 1.4 comes from. So the gamma 1.4 stand for diatomic gas. So that this is where we know the type of gas molecule is. Okay. For polyatomic, if you substitute into the equation here, so we get 1.33. Okay. So you must memorize this to state to determine whether the gas molecules is the type of the gas molecule, whether it is a monoatomic, diatomic or polyatomic. Okay, hope that you understand. Okay, so next we go to question B. Okay, for question B, we want calculate the final pressure of the gas. Okay, to use the formula, so be careful which formula to be used. So mention here is adiabatic compression. Adiabatic compression. So you must memorize the adiabatic equation here. The relationship between P, V and T. Okay, this is the adiabatic equations. So we have P1 V1 to the power of gamma equals to P2 V2 to the power of gamma. T1 B1 to the power of gamma minus 1 equals to T2 B2 to the power of gamma minus 1, and P1 to the power of 1 minus gamma T1 to the power of gamma equals to P2 to the power of 1 minus gamma and T2 to the power of gamma. Okay, so which one to choose? So you read the question. What's the question give? The information given in the question. So you are given T1. Okay, here the volume V1. Okay, and then we have P1, and the compression becomes 1/3 of its original volume. So that's mean this is V2. Okay, so which one to choose? That's mean we choose the first one. P2 we don't know. Okay, final pressure is P2. So that's mean we choose the first equation because T is not given. Okay, T2 is not given. So we choose first question. Okay, so now P1 V1 to the power of gamma equals to P2 P2 to the power of gamma. So we substitute all the values given. P1 1.013 times 10 to the power of 5. Then V1 to the power of gamma given 1.4. P2, okay, the volume becomes 1/3 of the initial volume. So 1/3 of the V1, okay, V1 is given, okay, 3.5 times 10 to the power of negative 3. Okay, so substitute everything. Actually, you don't substitute, also cancel out, right? The V1, okay. And we get P2, okay, rearrange the equations here. So we get P2 4.72 times 10 to the power of 5 Pascal. Okay, so this is our answer for question B. Okay. So in the exam, STPM exam, formula is not given. This formula not given. So you need to memorize all this formula. And you need to know the derivation also. Who knows derivation question come up. Okay, so next question B. Next we go to question C. Okay, question C, determine the amount of work done on the gas. Okay, so we are going to find work. So we choose work for adiabatic compression. Work for adiabatic. Okay, work for adiabatic change is this formula. Okay, so you can use straight away the formula. No need to memorize. No need to. Derivation also need to know the derivation. But for this question, it doesn't ask. So you just straight away use the equation. So the equation for work done for adiabatic change is 1 per gamma minus 1. So bracket P1 V1 minus P2 V2. So we use this equation and substitute all the values given. And P1, okay, P1 and then V1. Okay, 1 is the initial, 2 is the final. If gamma minus 1. So if you memorize as 1 minus gamma, here must P2 V2 minus P1 V1. So you must be really very careful the way you memorize the equation. Okay, so student mistakes every year with this equation because different book give different formula. So if gamma minus 1, here means P1 V1 minus P2 V2. Okay, so now the answer is minus 490 joule. Okay, so why we got negative here? So we check the question said compression, so it suits our answer here. So compression means we should get negative answer, right? So there we got negative, and then another one is work done on the gas. Okay, next we go
Madam
to
Rosmaya,
okay.
Madam Rosmaya, can I announce the second digit code? Okay.
Okay.
So, student, our second digit code for today's class is number 8. Okay, number 8. All right. So you can continue, Madam Rosmaya. Thank you.
Okay, jot that down. Number 8. Okay, now we continue with question 3. Okay, we read the question first. A gas is compressed at a constant pressure of 0.800 atmosphere from 9 liter to 2 liter. So in the process, 400 joule of energy leaves the gas by heat. So what is the work done on the gas, and then what is the change in its internal energy? Okay. So what is given in the question? The information given, pressure, and then the volume change to 9 liter to 2 liter. So that means we have final and initial and final volume. Pressure is constant, so it's P, and then we have energy 400 joule. Okay, then we are going to find work done. Okay, question A, the work done. So there are 3 formulas, including just now for adiabatic, for work done. Okay, you must know also how to get this formula of work done. Derivation from the general definition for work. General definition for work is this one. Work is integration of P with respect to V. Volume, P is pressure. Okay. So the changes of V from V1 to V2 or V initial to V final. So from there, you get these 4 kinds of equations for work done. Okay, so I don't want to go detail in this one. Maybe later if we got time, we go the fourth one, how to derive this. Okay, so now this is constant pressure, so you choose which one? Okay, so we choose the first one, P delta V. Okay, because it's constant pressure, so you use this formula. Okay, so for this formula, you just substitute the pressure given, but pressure is in atmosphere, so you need to convert it to SI unit Pascal. So to convert it, you just use ratio method. This one you've learned in the secondary school already, so you can use ratio method. That means you multiply the 0.8 atmosphere times the 1.013 times 10 to the power of 5 Pascal. Okay, convert to SI unit. Okay, for the volume also convert to SI unit. So 1 liter is 0.01 meter cube. So convert it to SI unit, meter cube. So that means the changes is -7. Okay, -7. So you times 0.01 meter cube to convert it to meter cube. Okay, so you get -567 joule. So do you realize that we get negative here? So why we get negative here? So check the question. It is compressed, right? So you can why you get negative is because the question also mentioned compressed. So your final answer should have negative there. So if you got positive, so that means something's wrong with your answer. Okay, another one here, work done on the gas. So you should get negative answer. Okay, so next we put the answer here. Okay, then we go to the question B. What is the change in its internal energy? Okay, next question, internal energy. So internal energy is delta U. Okay, so delta U, to find delta U, so you know work and the heat Q, so you can use first law of thermodynamics. Okay, write down the first law of thermodynamics. Q equals to delta U plus work done. Okay, now substitute the 400 joule of energy, but you must substitute with the negative. So why negative? Why substitute negative into the heat here? Okay, so because it's the energy leaves by the gas. Okay, so there's a heat loss. So if heat loss it is negative. So you must be very careful with the sign positive or negative. Okay, now the internal energy substitute here also, and you get internal energy positive 167 joule. So the internal energy you get positive. Why we got positive here? So that's mean there is the increase in internal energy. Yeah. Sorry, I have sore throat. Too much talking. Okay, so positive means there is increase in internal energy. So that's why very important for you to substitute the sign together with the value. Okay. So for the memorization of sign, okay, so delta Q positive means the heat energy supplied to the gas. If negative means the heat energy lost by the gas. Okay, if internal energy positive, that means increase in internal energy. So here is positive, right? So this is increase in internal energy, and negative mean decrease in internal energy. And W positive work done is the work done by the gas during expansion. So for compression is negative. Okay, memorize all this. Okay, so next we go to question 4. Question 4. Okay, so we read together the question first. When an ideal gas is taken from the state X to Z along XYZ, here XYZ, so the heat supplied for the stage XY and YZ are 182 joule and 65 joule respectively. So the temperature of the gas at XYZ are respectively 300 Kelvin, 400 Kelvin and 450 Kelvin. So what is the increase in internal energy of the gas during the process XYZ? And then explain why the increase in internal energy is different from the value of the total heat supplied. Okay, and then B, determine the value of gamma, okay, the ratio of principal heat capacity of the gas, and then state whether the molecule of the gas is monoatomic, diatomic or polyatomic, and then calculate the number of moles for the gas. Okay, so we do question A. Okay, the question asks internal energy during the process, and we label to the diagram what is given so that we can reduce our careless mistake. Okay, so QXY is 182 joule, QYZ is 65 joule, and then the temperature also label. So here 300 Kelvin, here 400 Kelvin, and here 450 Kelvin. Okay, to avoid careless mistake, so we label in the diagram. Okay, so we do one by one for YZ first. So increase in internal energy during process XYZ. So we find internal change in internal energy from Y to Z. Okay, from Y to Z, we use first law of thermodynamic. Okay, Q equals to delta U plus work done. Okay, so this Y to Z, there is no changes in volume. So it's a vertical line. So it is understood that the work done is zero. Okay, so that means the internal energy is equals to the heat supplied. Heat supplied. So that means internal energy for QYZ is equals to delta U. So that means delta U equals to 65 joule for changes of the gas from Y to Z. So we keep this for a while because next we are going to find internal energy during the process X to Y. Okay, X to Y. For X to Y, if you use first law of thermodynamic, okay, we have here two unknown variables, two unknown. So we cannot solve using the first law of thermodynamic. Okay, so instead of using, we cannot use this equation. So therefore we use another equation, another equation. So we choose the delta U equals to NCVM delta T. So remember the first question, we have derived this delta U equals to NCVM delta T. So this is the fixed formula, delta U equals to NCVM delta T. Okay, so we substitute the CVM. Substitute CVM. So to find the CVM, okay, we use the YZ because CVM is constant. Is constant. So we find CVM first. We are going to substitute in here. So using the YZ, the Q is 65, okay, and CVM, so the changes in temperature is 450 minus 400, initial minus, final minus initial, so you get CVM 65 per N times 50. Okay, so now you can substitute into here to get the internal energy for X to Y, change in internal energy X to Y. Okay, now we can cancel the N. Okay, so you get 130 joule. Okay, 130 joule. Okay, so now from these two values, delta UX, delta UYZ, XYZ, right? So the total will be 130 plus 65. So it's 195 joule. So that's the total of energy equals to 195 joule. Okay.
Okay, Madam Rosmaya, before we continue to question B, can we break for a while for
Okay,
the
so we
iklan,
take a break.
for the advertisement? Yes.
Okay, stay tuned.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata gancaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay, welcome back, student. I give back to the Madam Rosmaya to continue her presentation. Okay, Madam.
Okay, thank you to our moderator, Cikgu Non. Okay, so we've done question 4A. Okay, back to the question now. So internal energy, we get 195 joule. So now explain why the increase in internal energy is different from the value of the total heat supplied. So total heat supply is, okay, we have Q X to Y 182 joule and Q Y to Z 65 joule. So the total is 65 plus 182. So we get 247 joule. Okay, so can you see the difference or not? So the increase in internal energy is different from the value of total heat supply. So why is this so? Okay, because there is work done from state X to Y, okay, to increase the volume of the gas. So because of the work done, so that's why it's different in values. Okay, we have here teacher Zanaria with us. Okay, hi teacher Zanaria. Thank you for dropping by. Okay, so now we go to question 4B. Question 4B. Okay, question 4B, determine the value of gamma, the ratio of principal heat capacities of the gas, and then state whether the molecule of the gas is monoatomic, diatomic, or polyatomic. Okay, so gamma, we're going to find gamma. Okay, the formula of gamma, okay, is CPM per CVM. Okay, memorize this formula. Okay, we've done this in the previous question. Hopefully, by right now, you memorize the formula already. Okay, so CPM per CVM. Okay, so to find the CPM and CVM, okay, from the Q equals to N CVM delta T here, actually we've done this in the previous question. Okay, so just repeat it. Okay, CBM is 65 per n times 50. This is the CBM. So we do the same for QXY. Okay, QXY is a constant pressure, so we use formula N CPM delta T. Okay, so we get CPM equals to 182 per n times 100. Okay, so now we substitute this into here, we get gamma. Okay, cancel the n. So do you realize that n not given, number of moles not given in the question because it can be cancelled out. So we get gamma 1.4. So for 1.4, what is meant? The gas is the monoatomic, diatomic or polyatomic? So if 1.4, that's mean the gas is the diatomic. For polyatomic is 1.33. For monoatomic is 1.67. Okay, memorize that. So if cannot memorize, so you memorize the formula half FR for CBVM and half F bracket F plus 2 times R for the CPM. Okay, use the relationship between CBM or CPM with degree of freedom. Okay, so we put this here next to the question B. And now the final question C. Calculate the number of moles for the gas. Okay. So calculate the number of moles for the gas. We want N, and number of moles. Okay, so CBM equals to 5 per 2R. So CPM equals to 7 per 2R. This one is from the formula half FR and half F plus 2R. So you substitute the F, 3, 5, 5 for the diatomic. So we know that diatomic means the degree of freedom is 5. So you substitute into here, formula half FR. So CVM will be 5 per 2R. So CPM is 7 per 2R. Okay, so choose which one now? Which one? Choose which one for the we are going to find N, right? Okay, choose either one. It's up to you. So let's say we choose the CVM equals to 65 per N times 15 here. So we choose this one. So you get N equals to 0.0626. Okay, mole. Okay, you can also choose this one. You will get same answer. The CPM equals to 182 per N times 100. Okay, so if you choose this one, okay, you get same answer. There, you substitute this CPM into here. So you get same answer. So it doesn't matter which one you choose. Okay, next we've done for question 4. So we go to question 5. Question 5. So during the compression stroke of a certain gasoline engine, the pressure increases from 1 atm or 1 atmosphere to 20.0 atmosphere. So if the process is adiabatic and the fuel-air mixture behaves as a diatomic ideal gas, so by what factor does the volume change? And then by what factor does the temperature change? And then C, assuming that the compression starts with 0.016 mole of gas at 27 degrees Celsius. So find the values of Q, W, and delta U that characterize the process. Okay, sorry, wait.
It's okay, Madam Rosmaya. Maybe I can announce our third digit code.
Okay.
Okay, before we solve this question. So class, the third digit code for today's class is number 6. Okay, please jot it down, right? Okay, number 6. Okay, so we wait our last digit code. Okay, Madam Rosmaya, you can continue. You can proceed with the presentation. Thank you.
Okay. Okay, got technical problem just now. Sorry. Okay, now we go to question 5. Question 5. During the compression stroke of a certain gasoline engine, so the pressure increases from 1 atmosphere to 20 atmosphere. So this is the change in pressure. Pressure 1 and pressure 2. Okay. So the diatomic, so what does this mean? Diatomic gas, so that means the F equals to 5. S equals to 5. Degree of freedom. For the monoatomic is 3, for the polyatomic it is 6. Memorize that. Okay, so but what is meant by factor? Okay, so factor means ratio of V2 to V1. Okay, so the questions one actually the ratio V2 to V1. Because this is volume change, right? So V2 per V1. So this is the adiabatic change. So to get the V2 to V1, we can get from this formula. Okay, we can get from this formula. Okay, so we choose this formula. Then P1 V1 to the power of gamma equals to P2 V2 to the power of gamma. So we rearrange the equation so that we can get V2 per V1 on the right side. Okay, then we bring gamma here, change position. So you get P1 per T2, P2 bracket 1 to the power of gamma. Okay, for the formula of gamma, okay, memorize this. Okay, now we can calculate for the gamma where this is diatomic. So we use these two equations, substitute the F into here. Okay, so F is 5. So we get gamma 7 per 5. Okay, 7 per 5. Okay, then we substitute 7 per 5 here. So we get V2 per V1 equals to bracket 1 per 20 to the power of 5 per 7. And the factor is 0.118. Okay, the factor is 0.118. Okay. Okay, so this is first question A. Next is by what factor does the temperature change? Okay. Okay, so if just now V2 per V1, so if temperature change, factor of the temperature change, so that means T2 per T1. So which question we can choose now is the second equation. Okay. You can choose the third one also, but the second one will be easier because T1 here got no power here, gamma, right? So we choose the simpler one. Okay, so we rearrange the equation to get T2 per T1. Okay, so to get the here V2 for V2 per V1, so that's mean gamma minus 1 here become negative, bracket gamma minus 1. So you must know how to change this equation. Okay, you've learned in secondary school already, okay, using math. So you get this V2 per V1 to the power of negative gamma minus 1. Okay, so now we substitute the 7.5 just now into here. Okay, and the volume change is 0.118 from question A. So you get 2.35. 2.35. Okay, so another method we can use is P1 V1 per T1 equals to P2 V2 per T2. Okay, you can use this. Okay, so T2 per T1, rearrange the equation. So we substitute the pressure. Okay, 20, final pressure, initial pressure. Do you realize that we didn't convert this atmosphere to Pascal unit, right? SI unit, because we can cancel the unit. This is in the multiplication form, right? So you can cancel out. So we don't have to convert it to SI unit. And then for the V2 per V1, we can substitute from the question A. Answer from A. Okay, so you calculate, you get same answer, 2.35. Okay, same answer. Okay, so done for question B, and then final question C, 5C. Okay, assuming that the compression starts with 0.016 mole of gas at 27 degrees Celsius, okay, find the values of Q, W, and delta U, change in internal energy that characterize the process. Okay, so Q, heat energy, work done, and internal energy, change in internal energy. Okay, so in this C question, you are given N, okay, N, and then temperature, okay, initial temperature. Okay, so Q equals to 0. Okay, Q equals to 0. Why you know is Q equals to 0? Okay, because it's adiabatic. Okay, adiabatic. So the process is the adiabatic change. So for adiabatic change, the special characteristic is no heat is allowed to enter or leave the system. So that's why it is understood that the Q is 0. Okay, Q is 0. Okay, now for the work done, you can use this formula. For the adiabatic change, for the adiabatic change, so you can use this work done, and because the PV here you can use nRT, and number of moles is given here, right? So you can use formula PV equals to nRT. Okay, now gamma from the previous we calculated already, right? So the gamma is 7/5. Okay, so now substitute everything. Another one is temperature. So the initial temperature is given 27 degrees Celsius, and the temperature factor change of temperature is 2.35. So we can have the relationship between T1 and T2. So we cross multiply, so we get T2 equals to 2.35 T1. Okay, so you can make use of this initial temperature into the change in temperature here. Okay, so now let's start substituting all the values. Okay, so NR here factor out. We get NR per gamma minus 1. So bracket is T1 minus T2. Okay, so don't forget to convert the temperature to Kelvin. Kelvin. So 27 degrees Celsius plus 273 to convert to Kelvin. And for the T2 is 2.35 times T1. Okay, so 2.35 times the 300 Kelvin. Okay, then the gamma also. Okay, here substitute into here. Okay, everything substitute. Then the answer for work is negative 135 joule. So let's check why we get negative here. So it's a compression. So it's a compression stated in the question. So that's mean we got work done negative. Should be negative for final answer. Okay, so now that's answered the question for work done. Next is the change in internal energy. Okay, so for change in internal energy, okay, Q0 we put it here, and the work done we put it here because we need space for delta U, internal energy. So for internal energy, we can use First Law of Thermodynamic because we know Q and we know W. So we can find internal energy. So internal energy will be, okay, substitute Q0 and work done negative 135, and the internal energy is 135 joule. Okay, positive. Okay, so there is another method. Remember, sometimes you can use more than one method. Okay. Okay, before we continue to one more method, so for to answer the how Ching Teng, where can I refer to the previous lessons? So you can go to the apps, Academy YouTuber apps. You can download there's a live tuition there, okay, or you can go to my channel, So, and subscribe my channel so that you can you don't miss any of the lesson, and you can refer to the previous lesson also. Okay, How Ching Teng. In the Academy YouTuber apps also got live tuition there, live class, and a lot of videos, PDPC physics videos there. Okay, How Ching Teng. Okay, so next, another method, we continue with question 5. Okay, another method, you can use this formula. So we derive this formula already, right, in the question 1. So delta U equals to NCVM delta T. So you substitute the number of moles here. Because it's given number of moles, right? So we can make use of this N. So you substitute N 0.016, and then CVM is half FR. So half F is 5 because it's a diatomic mentioned here. So number of degree of freedom is 5, and then R is 8.31. Okay, so delta T, change in temperature. T1, T2 and minus T1, final minus initial. So final will be 2.35 T1 and then minus initial T1. So don't forget to convert 27 degrees Celsius here to Kelvin. If not, you get you get wrong answer. Okay, so we calculate, we get same answer, 135 Joule. So I didn't put unit here. So be careful if you don't put unit together with your answer, so you won't get marks. So I didn't put unit here. So you must put unit. Okay. Okay, so this is question 5. Okay, you are welcome, How Ching Teng. Okay. Okay, next we go to question this is okay, question 6 I didn't give in the PDF question. Okay, link I put in the description below. Okay, but it's okay, we still got time, right? So this is extra means lesson for us to do revision, okay, because we still got time. So we are going to prove this formula, where we got this, where this formula comes from. Prove that the work done during adiabatic chain is given by work equals to 1 per gamma minus 1 bracket P1V1 minus P2V2. Okay, we use this equation. We use this equation. Okay, the first one, P1V1 to the power of gamma equals to P2V2 to the power of gamma. And we realize that it's constant because they are equal, final and initial. Final and initial equal. So that means PV to the power of gamma is constant. Okay, so let's put this constant as K. Okay, so that easier to derive later. So we just put this as one symbol K. Okay, now the P is K times V to the power of negative gamma. So we bring this to the right side. Okay, so it's become V to the power of negative gamma. Okay, now we use the definition for work done. Okay, so the definition for work done is the integration for P with respect to V, okay, where the changes of V is from V1 to V2. Okay, so you substitute this into here. Okay, now K is constant, so we use integration rules. K is constant, we can bring to the front. So we can integrate the V, the V to the power of negative gamma with respect to V. So use integration rules. We can plus the power here, negative gamma plus 1, then divided by negative gamma plus 1. Okay, you've learned this in Maths T, Maths T, or at Maths Form 4, Form 5, I think you've learned this already, right? The simple integration. Okay, so now after you integrate, so you substitute V2 and V1 into the here. So this one can bring to the right side because also constant. Gamma is constant. So we bring here. Okay, then V to the power of negative gamma plus 1, we substitute V2 into here and V1 into here. Okay, so what we get, V2 to the power of negative gamma plus 1 and then next minus V1 to the power of negative gamma plus 1. Okay, all this is integration rules. And you get, continue from here. Okay, what you get? We change position, okay, because actually not change the you don't change the position also is okay. Just to have a nice look of this. So negative gamma plus 1 is the same as 1 minus gamma. So it's up to you want to change or not. Okay, so now we substitute back k because we are going to combine this v2 to the power of 1 minus gamma. So k just now is pv. K is just now what we get p. K is pv to the power of gamma. K is pv to the power of gamma. So it's a constant. So we substitute back into here. Okay. So this is V2, so we substitute here P2, V2. Okay, because it's constant, right? So it's up to you to put P1, V1 to the power of gamma or P2, V2 to the power of gamma. It's up to you. But because here is V2, so we put P2, V2 to the power of gamma. So here is V1, so therefore on this bracket we put P1, V1 to the power of gamma. Because we want to pair them correctly. Pair them correctly so that we can simplify simplify to one. It looks more simpler. Let's check what happened. So this V2, the power gamma plus 1 minus gamma, so it's simplified to P2 V2, right? So we use product rule you've learned in Form 1, Form 2, Form 3 actually. This one is Form 1, Form 2, Form 3. Okay, use products rule. So the power here, this term simplified to P2 V2 and this one simplified to P1 V1. So there, you proved the formula already. Very simple. So if this question come out in the exam, so this is the method. So work, but be careful. The given in the question is gamma minus 1. So you just change it back. So 1 minus gamma. So gamma minus 1 means the P2, P1 V1 in front, put in front. So 1 per gamma minus 1 is P1 V1 minus P2 V2. Okay. So proven the formula. Okay, so that's all for discussion today. Okay, see you in the next lesson. And I give back I pass this session back to Cikgu Non. Okay, Cikgu Non.
Okay, Alhamdulillah, we have reached the end of today's session. Congratulations to those who can follow our session from the beginning till the end. Before we end our session today, I will announce the fourth or the last digit code for the credit claim. So the digit is number 4. Okay, number 4. So all of you, please stop posting your comment for a while, and if you haven't clicked the subscribe button, please do so. Make sure it turns to grey color, okay? And activate the icon bell so that you will not miss the next class session. Then, if you find that the lesson was beneficial, click like and share to your friends on your social media. Spread and share the goodness. Once complete, type done on the chat box before the certificate link is given as a token of thank you for your dedication in joining the free online class today. Okay, link for the certificate and link to claim credit are all already given in the chat box, right? So with the access code is hashtag kelas AYU So please take note, the link will end half an hour after this live. Make sure to use the EDD email to log in. Incorrect email use will not be entertained. If you haven't got one, please apply. The link to apply the EDD email is also given in the chat box. Okay? So if you wish to get more information on the online class, go to academyyoutuber.com, and to those who haven't joined EDD Junior Telegram, please do so. Okay, so once again, I would like to thank all students for joining our tuition class today. Remember that the more classes you join, the more credit you can claim. So feel free to share this free tuition class to your friends and teachers all over Malaysia. This is a collective effort from all the teachers throughout Malaysia for all the students throughout the country. Thank you too for being a YouTuber Academy supporter too. I think that's all for now. See you in another session. Do not forget the hashtag bermula percuma, selamanya percuma. Stay safe till we meet again next time, same day and same time. Thank you. Assalamualaikum and bye-bye. Okay.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang. Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.